you can, if you want, explain a little bit more about your background.
Well, I think the mic does not work very well.
The microphone will work if you put it close. And put it just very close like this and it will work.
Like this. Ah. To avoid any contamination. Well, thanks for being here so numerous, and thanks to the AFPG and its charming secretary to give us the opportunity to share today some of or a small part of our vast experience in the geothermal energy field. Where can I switch the slides? Press right or left. Ah, okay. So we heard a lot today about the construction and the creation of geothermal systems. Now the business of Aquaprox, the last 20, 30 years, the last decades, is to keep an existing system going, to keep it in shape. And our experience of the last 2, 3 decades was clearly that every problem that may come up in a geothermal system is based on the water side. That means 98% of the issues can be relied on the geothermal water. The remaining 2% are technical failures and personal errors, but we can neglect them. We have to cope as a chemical product producing company with the chemistry of the water in geothermal systems. Without going too far into the details, to the chemical details, I think we are running a little bit out of time and running out of energy as well. For the last decades, we tried to understand the chemistry of geothermal water to solve the upcoming problems. And in general, we are right when we claim that we have to understand geothermal water. Without going into the details, this is an average analysis of an average geothermal water coming from around about 4,000 meters of depth, and we marked in red the problematic elements. Without going into the details, those who are skilled in the art may know them. We have barium, we have lead, we have arsenic, we have chlorides, and this complex chemistry of a geothermal water gives problems that has to be solved with chemicals. It is not reasonable with a flow rate of 500 tons per hour to eliminate or to clean the water. So we can only cope with the remaining problems. That means to stabilize the troublemakers in the water or to eliminate the problems they will create. We do this with a selected range of raw materials. Without going into these details, you can see on the right we have acetic acid and carboxymethylated starch. It is a modified potato starch that is for the last 2 years, the focus of our interest, because it can replace many of synthetic products like acrylates or phosphonates. We can today, or we are convinced we can today replace at least 80-90% of synthetic products by or products from plant origin. Actually, we have an average of 45% of raw materials of the plant origin. As you can see at the right, you may know the others. They are at least biodegradable, but the blue ones are not from plant origin. The green ones are from plant origin, and it is a small part of our list of our raw materials, but the percentage we maintain. We have round about 40-45% of natural born products in our end products. Here we can see one example where or how our products will work. We have, for instance, heavy metal sulfides that we find in heat exchangers, and with one of our products, a mixture of 3 of them breaks down the heavy metal sulfides within a few minutes. And during the last weeks, last month, there is a recent project. We cleaned a lot of heat exchangers with our cleaning product PBS1. But the better way that we learned as well during the last 20 years is to avoid those problems. That means that we have to do a downhole injection to protect all the geothermal system right from the beginning. We have to do a downhole injection with a film forming technology to protect the whole system right from the beginning. Without going into these details, it is a film forming technology that is injected downhole to treat the incoming water from the first minute, if you want to. And it goes through the entire system, through the heat exchanger, where we take out the calories, and it is re-injected during the 1 or 2 re-injectors to keep the system even on the re-injecting side in shape. Now, when we know how our products work and how they protect against corrosion, there was still one last question, meaning is by a downhole injection the entire system protected, or maybe the protection is limited to the injection site. That means there where we inject the product, downhole here, the water goes up through the heat exchanger and goes back to the dogger in this case by 1 or 2 injection pipes. The question was, during the last years, is the re-injection site as well protected? So we had to create a system to monitor our product or to pursue the large extent of a geothermal system from round about 5, 6, 7, 8, 9, 10 kilometers makes it necessary to follow the product during its long way or its long journey through an entire geothermal system. So we had to create, on demand of some of our customers, but it was in our interest as well, we had to create a control system to pursue or to follow the product during its long journey through the entire system. Well, the key concern is the inhibitor dosage sufficient to protect both the producer, that we know because we measure iron values and the water parameters in the level of the heat exchanger, so we know exactly what is going on in the producer. But it is very difficult to take a water sample at the end of the injector. So we have to check at least if we do have enough of our inhibitor before it goes through the injector. It was the key concern of our R&D during the last 12 months, and it seems easy. You should measure by some or another control unit the concentration of the product after the water goes through the heat exchanger, and you will know it. But it took around about 12 months to create a kit that is capable to precisely measure the concentration of some ppm of an injector, of an inhibitor, when we have all the water chemistry who comes along with the product. We have some ppm of product, and we have some 1000 ppm. That means more than 1000 times more of water components like salts, chlorides, lead, strontium, and whatever you saw on slide number 4. So the parameters are almost constant. The production well has a pH of 6 and a temperature of 70 centigrade. The reinjection well, the same pH, of course, and a lower temperature. After around about 12-14 months of R&D, well, we reproduced a control kit that eliminates in the geothermal water the interferences like chlorides and like iron, and it colors our treatment product. The remaining color, or the upcoming color, is proportional to the concentration of the product. So we bring the test tube in a photometer, and we can measure with the precision of roundabout 0.1 ppm the product concentration. So now we are ready to follow the product through its way through the entire system. So we know how to protect the system, and we know now if or if not we need a second dosing pump to protect as well the reinjection systems. For the moment it is ongoing R&D. We come to the conclusion that round about 50% of the initially injected product remains in the producer, and the other 50% are still in the water to protect heat exchanger and the reinjection tubes. But we have yet only measured 5-6 customers from our 36 customers around the Paris region. So we will know during the next month whether or not it is necessary to protect the reinjection system by a second dosing pump. This is ongoing R&D, and I hope it was clear where we are and what we are doing.
Thank you very much. Interesting to hear also that you're making geothermal even greener with your new product developments. So now